We're going to review the math calculations that can be done if you're looking at a velocity graph. And there are two things that we can calculate. The first thing that you need to remember is that the slope of velocity equals acceleration. So if you calculate how steep the velocity graph is, that's telling you the acceleration of the object. Notice this first segment of my graph is flat. That means that the acceleration equals 0. There was no slope. Similarly, the middle section of my graph is flat. So I'm going to write acceleration equals 0. The part of the graph that's interesting because it's actually slanted is the last segment. So I'm going to identify these 2 points. We have, let's see here. It looks like 5, -2. That's my first point. And then 6, 0. That's this last point. Slope is rise over run. And the rise is the y-axis. And the run is the x-axis. So in this case, the rise of the graph from -2 to 0, so it went up 2. Because it's going up, that just means it's a +2. And then the run went from 5 to 6. That's forward 1. So this particular graph goes up 2 over 1, which gives us a slope of 2. Because it's acceleration, the units are going to be meters per second per second. So remember, acceleration is the weird one. It gets seconds written twice. And if you look on the axis, those units are coming from what we already have on the graph. So velocity is meters per second, and time is seconds. And when you put this together, when you do meters per second with another second, that's why we have the extra s. So that's the first thing you can do with a velocity graph, is use the slope to calculate acceleration. The second thing you can do with a velocity graph is calculate displacement. So delta x equals the area under velocity. This is another fact that you just need to remember. So I can figure out how far this object moved by calculating the area under my graph. Notice that this graph can be broken into 3 segments. The first segment is a rectangle. It has a width of 3 seconds. You always have to look at the graph. And it has a height of 1. So if I multiply base times height, I get an area of +3. The second one has a width of 2. It goes from 3 to 5. And it has a height of -2. If I multiply base times height, I get an area of -4. And this last shape is a triangle. It has a width of 1 second, and the height is -2. It's the same height as that square. When we calculate the area of a triangle, we do 1/2 base times height. So if I put that in a calculator, I'm going to get -1. By putting these pieces together, I can figure out the full displacement of this object. So we have +3 -4 -1. If I put all those numbers in a calculator, I get -2. That means that this object from the beginning of the story to the end of the story, the total displacement is 2 meters towards the detector. I'm using the word towards because it's negative. So this object has moved 2 meters towards the detector or towards the reference. And it does have units. Because it's displacement, these units are going to be meters. Once again, those units make sense if you look at your axis. This time we're going to multiply meters per second times seconds. And what happens is that the letter S cancels out, and all we are left with is meters. So again, there are 2 calculations we can do on a velocity graph. We can calculate the acceleration by looking at the slope, or we can calculate displacement by looking at the area.